You're going to need page 449 to complete your warm-up. You're going to plot each point on the grid that is provided on that page. This is an online lesson, so feel free to log into your Great Minds account if you have that. It says, Maya designs shirts. She needs to choose a print shop that can print and ship the shirts. Her customers want their orders as soon as possible. Maya gathers shipping times and other data for several different customers. In this lesson, shipping time refers to the time from when the customer places the order to when the item arrives. Which variables can you use to predict how long it will take an order to reach a customer? Select all that apply. The shop's distance from the customer, the cost of shipping, the shop's customer rating. Well, the distance from the customer is probably going to impact how long it takes. And the cost of shipping may also impact how long it takes. You might be able to pay more to have it arrive sooner. Maya wonders whether the distance from a shop to a customer is related to the shipping time. Select a shop to view the shipping time to a specific customer and explore this relationship. Well, here's a customer, and here's a shop that's close. It says it'll take 2 days. Select a few more shops. What do you notice about the shop's distances and shipping times? Let's pick one that's far away. That says it'll take 6 days. Even farther will take 9 days. This one is kind of in the middle at 3 days. We will use this graph to display the distances and shipping data. So we're going to represent shop A as a set of coordinates using 125 and 4. So it looks like we're broken down into 50s here. So this would be 50, 100, and then 125 is right there in the middle, and go up to 4. Then let's graph shop B. 200, up 3. So even though this was farther, it does take a little bit less time. 275 took 14 days. 300 took 7 days. 425 took 10 days. 450 miles took 5 days. 475 took 11 days. 500 miles took them 8 days. 525 took 6 days. And 675 miles took 9 days. One data point is 425.10. What does this ordered pair represent? This ordered pair indicates that a print shop 425 miles from the customer will have a shipping time of 10 days. You can see the distance from the customer is on the x-axis, so that's at 425, and the shipping time in days is the y-axis, so that represents the 10. Maya gathers and plots the distances and shipping time data for a different customer's location. So each one of those points represents a different shop going to the customer. This is the scatter plot of the data Maya collected. Look at the maximum and minimum y values. Select an appropriate scale for the y-axis by adjusting the numbers in the table. So we have a maximum y value of 11 and a minimum y value of 3. So instead of counting by fives, I'm going to start at 0, and I might end at like 12 or 13, so that way I can still see that 11 on the graph. Maya wonders whether the shipping cost is related to the shipping time. She gathers data for a different customer's location. Select a shop to explore this relationship. So a $4 shipping took 4 days. Let's look at a more expensive one. A $9 shipping took 3 days. A cheaper one took fewer days. Let's look at another cheap one. This one was cheaper, but took more time. There doesn't appear to be much of a pattern. We saw lower prices would take a long time or a short amount of time. We saw more expensive ones could take longer or shorter as well. Now let's put it in a scatter plot and see if we can find a trend or a pattern based on what it appears to be from the graph. So we're going over for $4 and up for 4 days. $3 and 2 days. $4.50 and 6 days. $5.50 and 4 days. $6.50 and 3 days, $7.50 and 5 days, $9 and 3 days, $0 and 9 days, $8.50 and 2 days, $2.50 and 7 days. And we can adjust the scales so that we can see those points more clearly. It says, Maya wonders whether the shops with more short color choices have shorter shipping times. She gathers data for a different customer's location. The results are shown. Do you think there's an association between the two variables? Explain. Not really. The data points are all spread apart or spread out, and there doesn't appear to be a pattern. Even in the last one, they were pretty spread out, but it does appear that there's a slight downward pattern to it. So by us looking at some of the locations for shipping on this one, we didn't really see the pattern very much. But when you look at it in a graph, you can kind of see that there's a downward trend to these data points. Sure, there are some points that maybe don't follow that pattern, but for the most part, they do follow a typical downward pattern, meaning the more that you spend, the less shipping time it'll take. But in here, we don't see much of a pattern at all. Maya wonders whether the number of farms in each town where the print shop is located is related to the shop's shipping time to a customer. Just for fun, Maya gathers data for a different customer's location. Do you notice an association in the data set? Do you think more farms might cause longer or shorter shipping times? There does appear to be an association, and it appears to be an upward pattern. We could say that the other way. It has a positive trend. As the number of farms increase, the shipping time also increases. But it does ask, do you think that it causes longer or shorter shipping times? I do not think that more farms cause longer shipping times. There could be a different reason for the extended shipping lengths. If you live in a farm town, you might know that sometimes the farm equipment can cause some traffic delays. So maybe it's related to the tractors on the road and not the farms themselves. Or maybe there's other things that are taking place in the town that are impacting the shipping times. Maya wonders whether the number of restaurants within a 5-mile radius is related to the shop's shipping time to a customer. She gathers data for a different location. Do you notice an association in the data set? And do you think more restaurants cause longer or shorter shipping times? There is a slight downward pattern to this, so there is an association in the data set, but it's not caused by the number of restaurants. Maya wonders whether there's an association between average customer ratings and shipping times to customers. Create a scatter plot that shows how you think average customer ratings relate to shipping times to a customer. I predict that if they have a higher rating, it's going to take less time. And as it has a lower rating, it's going to take more time. And we're just creating a scatter plot to follow a generic trend in our data. When a customer gets their items quickly, they probably will leave a better rating. Here's the actual data Maya gathered for a different customer's location. Do you think you can use the shipping time to a customer to predict the average customer rating? Do you think shorter shipping times cause a higher customer rating? Explain your reasoning. We may be able to predict the shipping time based on a review or a rating. For example, if you told me that the rating was 3, I might say that it's somewhere around 4 or 5 days. Do you think the shorter shipping time might cause a higher customer rating? We can't determine the cause. There could be underlying things that impact it as well. Perhaps it's the quality of the items. That is why they are leaving a good review. That is the end of lesson 11. Make sure if you weren't following along on Great Minds that you took notes in your workbook for this lesson.